Welcome to this practice activity. You can reinforce what you learn only by practicing what you've learned. To review the previous 4 lessons, I ask you to go through these 3 exercises, and for each of them, to perform 3 tasks. Remember that if you want, you can download the slides, the notes, and the spreadsheet for this practice activity, so that you can follow along better. For the first exercise, task 1 is, given a bond equivalent yield of 2.5%, calculate the semi-annual yield. Task 2, use the semi-annual yield to calculate the effective annual rate. Task 3, explain the main difference between the bond equivalent yield and the effective annual rate. For exercise 2, task 1 is to describe what yield to call represents for callable bonds. Task 2, given a callable bond with a face value of $1,000, a coupon rate of 5%, a market price of $1,050, and a call price of $1,020, callable in 3 years, calculate the yield to call. Task 3 is to explain why yield to call is important for investors holding callable bonds. Exercise 3 asks you for task 1 to explain what yield spread measures and its significance are. Task 2, given a corporate bond with a yield to maturity of 4% and a government bond with a yield to maturity of 2.5%, calculate the G-spread, and at last for task 3, interpret G-spread. Now, pause the video and get back when you want to check your answers. Now that you have gone through the practice opportunity, I can walk you through my solution. For exercise 1, I will only use the notes to show you the correct answers. To find the semi-annual yield, you only have to divide by 2 the bond equivalent yield. As a reminder, when you find yield to maturity, regardless of annual, semi-annual, or quarterly coupon payments, the yield is reported on a bond equivalent basis. It's always specified if a yield to maturity is reported as an effective annual rate. In fact, for task 2 to calculate the corresponding effective annual rate, we have to compound the semi-annual yield 2 times. We get 2.52%, a little more than the original annual bond equivalent yield of 2.5%, because of the compounding effect. Task 3 provides the explanation. An effective annual rate provides investors with an apples-to-apples measure to compare the yields of 2 bonds with different periodicities. Exercise 2 is about callable bonds and their yield measures. Yield to call, or in this case, task 2 was about yield to first call. Remember that you can calculate a yield to first call, a yield to second call, a yield to worst call. In this case, I'll use my spreadsheet, the one you've already probably downloaded. As is usual now, I've laid out the cash flows on the spreadsheet, considering a first call at the end of the 3rd year, as in the information provided. As you see here, the sum of cash flows in present value with a discount rate and arbitrary discount rate of 2% doesn't yield the same price. We can therefore use goal seek again, data, what if analysis, and goal seek. We know we set the cell with the difference between the sum of cash flows and the bond price provided to 0 by changing the discount rate. We get 3.85%. Alternatively, we could have used Excel's IRR function, like so, and the negative sign in front of the market price. More important is the fact that the IRR returns a periodic rate. If the periods are annual, as in this case, the rate is annual. If the periods are semi-annual, the rate is semi-annual. Or finally, Excel's function rate. For task 3, as you can find in the notes, yield to first call, in this case, is important because it provides investors with the potential return if the issuer decides to call the bond early, at the end of the third year. This can happen if interest rates fall, allowing the issuers to refinance at a lower rate, which might leave investors reinvesting their principal at a lower rate than anticipated with yield to maturity. Exercise 3 regards yield spreads, in particular G-spread. We see Z-spread again in one of the following lessons. The yield spread measures the difference between yield to maturity of a bond and the yield of a liquid government benchmark bond. It distinguishes between systemic factors affecting the bond price, represented by the government yield, and specific factors represented by the spread. This measure helps investors understand the risk premium for credit and liquidity risks. In Task 2, the G-spread is simply the difference between the two yields to maturity. And in Task 3, a higher G-spread indicates a higher credit risk premium, demanded by investors for holding the corporate bond instead of a risk-free government bond. It suggests that investors perceive the corporate bond as riskier compared to the government bond. Okay, this is all I've got for you now, and I'll see you in the next video.